Question 23. Again, let's kind of look at what the questions are. Approximate blank of women over 70 had blood pressures between that. And then let's just click on what's it want. It wants percentages. Okay, so we're getting into the normal curve stuff. And then approximately 68% of women over 70 had blood pressures between these two levels. Okay, have an idea of what we're going to need to do. So now let's come to the information. And this is important. We're told that blood pressures are normally distributed. We're supposing it. We're always, if it's normally distributed, there will be a mean. So the mean blood pressure is 133 with a standard deviation of 9. So they use these symbols for mean, 133, and a standard deviation. They use this one, or you can use SD. It's going to be 9. And then so basing these questions on it, we're using this fact that when we have a normal curve, let's see if I can, something like that, the mean is always going to be right here in the middle, so that we know is 133. One standard deviation, we're going to add 9 and subtract 9. So we plus 9 gets us here. 9 plus 133 is going to be 142. We also subtract 9 to get 1 standard deviation below. 133 minus 9 is going to be 124. And what we know from the books and from everything is that 68% is between 1 standard deviation above to 1 standard deviation below. So if we were to shade in this area, the percent, because everything under this curve is 100%, that this region from -1 standard deviations or standard scores to +1, that's going to be 68% right there. So actually we can answer this first question, or the second question first. It's going to be from 124 to 142. That's the one below to one above. So let's go ahead and put those in. So it's going to be 124 to 142. Now you could look as much as you will for why 168. There's not a lot of mathematical explanation on this. It just is because it is. It's actually how random events occur, and it's what makes a normal curve a normal curve. If it's not 68%, if it was 50%, it's not a normal curve, not a normal distribution. So normal distributions, what we define as a normal distribution, will have 68% between 1 standard deviation below to 1 standard deviation above the mean. That's the definition of normal. And the use of the word normal is different than what we do in English. It doesn't mean what we normally mean it to mean. Okay, so then the next question is, what does this 106 to 160 represent? So we come back to this. Well, if let me change our color back to this. If 1 below to 1 above is 68, two below to 2 above would be 95%. And then the last one we get is if we're from 3 below to 3 above, that's going to give us 99.7%. So when you're answering these, one of the things is, if you've gone over these a few times, they've always got this 75% in there. It's not one of the numbers, but it might get you if you haven't done the homework. But if you've done the homework, you'll know it's either 68, 95, or 99.7. So the thing is are these numbers, the 160 to the 160, are they 3 or are they 2? Well, let's just, down here where we've already got a start, let's go ahead and keep going. So if I add 9 to this, that'll get me 2 above, right? I've added 9 twice. 142 plus 9 is going to give us 151. And if I add 9 one more time, that's 3 standard deviations above, and that gets me to the 160. So what I found is 160 is plus 3 above. Would you want to guess that the 106 is going to be 3 below? Now you can do it. Subtract it one more time, and we get 113, and then a third time. Notice we subtracted 9. We subtracted the standard deviation 3 times. Drawing's not real good, but and you subtract this one more time, you get, did I do that right? No, not 113. I'm going the wrong way. Subtracting's harder to do than add. 115, that's going to give us 106 here. Okay, so 106 to 1, so this is 3 below to 3 above, and that is the case that we get over here, so that is the 99.7. So that's how we answer these types of questions.